Hello. With the previous class covering how to find the factors of a number, we will now proceed to finding or identifying or defining what a prime number is. Like I said in the previous lesson, before we define what a prime number is, we need a clear understanding of what the factors of a number is or are. So let's take a quick revision on finding the factors of a number. So I'll pick a simple number. So number 10. So we have to list the factors of 10. This is for revision purposes. Then we proceed to today's lesson, which is prime numbers. So factors of 10, like we said, we can have our here 1 and 10 always being the factors of the given number, which is 10. Then we begin from 2. Yes, 2 can divide 10 into 5 equal parts. 3 does not divide, so 3 can be in red. 4 doesn't divide. Then instead of us checking for 5, we can already see that 5 exists on the left side, on the right side of the hill. So that marks the end of our check. So we can list the numbers. Yeah, so now the factors of 10, we have 1, 2, 5, and 10. This is just a quick recap on finding the factors of a number. Now let's proceed to what prime numbers are. Prime numbers. I believe most of you have heard of this term, prime numbers. So when we say a prime number, it's any number having only two factors. So the key word here is only two factors. Only two factors. And what are those factors? 1 and the number itself. 1 and the number itself. So let's look at the definition for a prime number. We say a prime number is any number having only two factors. You should take note of the keyword here, only two factors. And then again, those factors should be 1 and the number itself. Exactly why we needed the explanation on how to find the factors of a number. Because if you are not able to find the factors of a number, then you wouldn't be able to identify if a number is prime or not. So let's take a look at an example. So given the number 4 as a number, let's check whether it's a prime number or not. So check whether 4 is prime or not. So we are checking whether the number 4 is prime or not. Now, like I said, the definition of a prime number is that it's a number having only two factors, 1 and the number itself. That means before we check, the first step in checking whether a number is prime or not is to do what? Is to list the factors. So the steps in checking if a number is prime or not, the first one is to list the factors of the number. To list the factors of the given number. List the factors of the given number. Then to count the number of factors. So basically, these are just the steps in finding or checking whether a number is prime or not. So we have to find the factors of the number. and then we continue to count the number of factors. This is because in our definition, we said a prime number has only two factors. So after counting the number of factors, we can now determine whether it's a prime number or not. So then let's proceed to finding the factors of 4. So quickly, we can have our curve here, 1 and 4 always being a member. So 2 can also divide 4 into 2 equal parts. But like I said, if you meet something like this, where we have repeated values both on the left and on the right, you can put it at the middle, like this, 2. And also when you reach a stage, when you reach that stage, that indicates the end of the check. So the factors of 4 are 1, 2, and 4. 1, 2, and 4. So we've done the first step, which is listing the factors of the given number. Now let's count the number of factors. So we have 1, 2, 3. So here we can see we have what? 3 factors. We have 3 factors. And that doesn't satisfy the definition of our prime numbers, which says that any number having only 2 factors, 1 and the number itself. 1 and the number itself. Because for any number, 1 and the number itself are always a factor, are always factors of that number. Like when we are drawing our curve, we always have 1 and a number on the left and the right side. So if you find any number in between, if you are able to find a number in between, if you find any number in between the number 1 and the number itself, then that doesn't qualify to be a prime number. So therefore we can say 4 is not a prime number. We can say 4 is not a prime number. I hope it's clear. So we listed the factors where we had 1, 2, and 4. Then again, we found out that we had 3 factors. But the definition of our prime number says it should have only 2 factors, 1 and the number itself. So let's look at another example. So let's check whether 5 is 5 a prime number. Is 5 a prime number? Is 5 a prime number? How can we check if 5 is a prime number? We follow our steps. We list our factors, where 1 and the number itself are always apart. 2 can't divide, so 2 can't divide. 3 can't divide. 4 can't divide. And now we are at our 5. So you could see for this number, we only have the factors to be 1 and 5. Any other number in between 1 and 5 wouldn't divide the number 5. Or we didn't find any factors in between 1 and 5. So for the factors of 5, we only had 1 and 5. And how many are they? 2. We had only 2. So there are 2 factors. There are only 2 factors of 5. And what are they? 1 and 5 itself, the number 5 itself. So now this satisfies the definition of a prime number. So we can say that, therefore, 5 is a prime number. 5 is a prime number. I hope you understand how to find a prime number or how to identify a prime number. You need to understand how to find the factors of that number, then you count the numbers. If it's more than 2, then we know that outrightly it's not a prime number. But if it's only 2 and it is 1 and the number itself, then we can consider it to be a prime number. Let's take a look at another example. So we can have the number 15 as an example. 15 is 15 a prime number? So the first thing is to list the factors of 15, where we have 1 and 15 already. I don't think 2 can divide 15, but 3 can divide 15. 3 can divide 15 into 5 equal parts. So mostly, even in finding whether a number is prime or not, if you get more than 2 factors, you don't have to continue to list the remaining of the factors. Because what we are looking out for is that we wouldn't find any number in between here. What we are looking out for is when I take these 2 out, the 1 and the number itself out, we wouldn't find any number on the hill. So once you find any number, you can pause and you conclude that 15 is not, or the number given is not a prime number. The number given is not a prime number. I hope it's clear. So once you have your 1 and the number itself at the ends of the hill, if you find any other number in between the hill, then we can say that that number is not a prime number. So in our definition, we can list our prime numbers. So let's see what our prime numbers are. So for our prime numbers, they begin from 2. So we have 2, 3, 5, 7, 11, 13, 17, and so on and so forth. You may notice that most of the prime numbers are odd numbers. So for example, you can find that we have our 3, our 5, our 7. These are all odd numbers. And the only even prime is 2. The only even prime number or prime is 2. So we have 2 as our only even prime number. The rest are odd numbers. That also doesn't mean every odd number is a prime number. So let's take note. Not all odd numbers are prime. Not all odd numbers are prime. This is because we even tested with 15 right above here. We tested with 15 and we saw that 15 had more than 2 factors. And as we know, 15 is an odd number. So 15 can't be a prime number. Although 15 is an odd number, it can't be a prime number. So for prime numbers, they should have only 2 factors. 1 and the number itself. 1 and the number itself. You can see that we didn't have 9. We don't have 9 here because the factors of 9, we have 1, 3, and 9. So this doesn't satisfy the definition of a prime number. I hope this explanation is clear. Good. So we proceed to prime factors. Prime factors. prime factors. So all what this means is that when you list the factors of a number, then you just pick out the prime numbers. So we can have a question like list the prime factors, list the prime factors of 18. List the prime factors of 18. So like I said, in our steps, first of all, what you do is you list, since you are looking for prime factors, that means first you list the factors of the given number. Then out of those factors, you pick you pick the prime numbers from those factors. So the first step is to list the factors, then you pick the prime numbers from the factors. So we have a question on the board which says list the prime factors of 18. Prime factors of 18. So what do we do? First of all, we list our factors of 18. Factors of 18. So we have 1 and 18. 2 divides 18 into 9. 3 divides 18 into 6. 4 doesn't divide 18. 5 doesn't divide 18. 6 does, but we find 6 already on our hill. So that is the end of our check. So now the factors of 18, we have 1, 2, 3, 6, 9, and 18. So for the first step, which is finding the factors of the number, we had 1, 2, 3, 6, 9, and 18. Now let's proceed to find the prime factors of 18. Prime factors of 18. So it's just picking out the prime numbers from the factors. It's just picking out the prime numbers from the factors. And if we are to apply what we've learned, the prime numbers from these factors are only 2 and 3. They are only 2 and 3. So these are the prime factors of 18. Prime factors of 18. Let's try another example. Let's list the prime factors of 21. Prime factors of 21. So first of all, what do? We find our factors of 21. So we have our hill where we have 1 and 21 as constant soldiers. 2 doesn't divide 21. 3 does. 3 divides it into 7. 4 doesn't. 5 doesn't. 6 doesn't. 7 does, but 7 is already on the hill. So that brings us to the end of finding the factors. So therefore we have 1, 3, 7, and 21. These are the factors of 21. Right. Then now we can proceed to find the prime factors of 21. So out of the factors we listed, which of them are the prime numbers? So we have this and this. 3 and 7. So then I put those over here, 3 and 7 to be my prime factors of 21. I hope this explanation is clear. If you have any question, please leave it in the comment section.
Low battery, please charge.
So that was my Bluetooth speaker warning me of low battery. These classes are recorded live. There are no editing. So whatever you hear is in real time. Yeah. Because I want you to understand and also to feel. Because sometimes I might make mistakes. If I edit them out, uh, you might think everything is perfect and everybody is perfect. No, we are all trying. So these videos are actually recorded in real time. There are no edits made to it. So yes, this brings us to the end of this lesson where we applied our knowledge in factors or from factors to identify whether a number is a prime number or not. Also, we try to find the prime factors of a given number. So to quickly recap, we say a prime number is any number that has two factors, 1 and the number itself. A prime number has only two factors. It has only two factors, 1 and the number itself. I believe the note is here. So any number having only two factors, that is 1 and the number itself, is considered to be a prime number. So we tested with 4, but we found out that 4 has three factors, so 4 doesn't qualify to be a prime number. Then we tested again with 5. 5 had only two factors, 1 and 5 itself. So we concluded that 5 is a prime number. Then we moved on to prime factors, where we said, first of all, you list the factors of the number, of the given number. Then out of those factors, you pick out your prime numbers. So this is why you need to follow the series, because we build up on our knowledge. First, we started off with factors, then we moved on to prime numbers, and now we are at prime factors. So if you skip any of the videos or if you skip any of the concepts, you will find yourself wanting in some of the topics. Yes, so this brings us to the end of this lesson. Subscribe and hit the bell icon for future updates. Stay blessed.